I always want someone to set up my jokes because then it makes, I'm like, oh. All right. So cast your minds back to the third day of school. You are in kindergarten. Your teacher asks you to count with him or her. And let's be honest, 99% of you had a lady kindergarten teacher. I've never actually ever met a male kindergarten teacher, ever. Do any of you know a male kindergarten teacher? Did any of you have a male teacher before grade 5 or 6? Really?
Yeah. Oh yeah.
Not phys ed. Stop it. That doesn't count. I mean, a homeroom teacher before grade 5 that was a man. Really? Yeah? Yeah. Until you're in middle school and high school. Yeah, I know. My buddy went there and taught, and he was like, yeah, it was weird, man.
Which I find it really weird. And all the teachers are so old.
You trying to say there, Roy? All right. So we have cast our minds back. We are in kindergarten with Mr. or Mrs. Bad Crumble. And Mr. or Mrs. Bad Crumble has said, children, let's count. And you all together say, 1, 2, 3. And that's when some of your peers got lost. Some of you could keep counting, but some of you were like, another one. So, huh? Yes, sadly, Josh, I have bad news for you all. The new math curricula for kindergarten, you are to leave kindergarten with the ability to count to 10. That's it. So, fortunately, we go to kindergarten for 10 months. So you can get one number each day. Each month.
Every day I'll have right up to 100. Yeah. And then I did up to 3,000. I was reading.
Okay. I will rewind to where I asked that. Oh, I didn't. So we all started counting together at 1. Yes? Naturally. No, you did not go 0, Mrs. Bad Crumble. You did not. You're a liar. So the natural numbers, 1, 2, 3. Now let's pretend we're not in kindergarten with Mrs. Bad Crumble. We're in pre-diploma honors math 10 with Mr. Myers. When could we stop counting? Never. Because we will count until infinity. Will we ever arrive there? No. Does infinity exist? No. It's a concept. It is not anything.
It's about as real as the color red.
What?
2 questions.
I have 2 answers.
I am glad you have it. One, is it a symbol for the amount of cardinal numbers? Like, it's that weird N, and it's like aleph and or something. That's the infinity of numbers. Yes, I did. Second, I don't think that kindergartners know the word another one. I think it's more like a 1, 2, 3.
No, every kindergartner knows another one because every parent gives their kid too much stuff and the kid says, another.
No, I just
all right. Now, the whole numbers are the natural numbers. They're all the naturals plus 0. So if we draw a culturally insensitive drawing, because I have to say they look like Russian dolls because I do not remember their proper name, and I'm aware that other Slavic countries have the same nesting dolls. So when I say Russian, I am not trying to exclude Azerbaijan or Georgia or Armenia or the Ukraine, but Yes. Thank you. Now I will remember. I did know that word. The natural numbers are the smallest group. Now that is very counterintuitive to say, isn't it? Because how many natural numbers are there? An infinite amount. So how can infinity also be the smallest?
Because there's different sizes of infinity.
Is there?
No, there's just infinities that include more.
There's stuff that goes.
There's infinities that include more. All right. Sure there are. All right. Now,
a sideways 8 that's small and then a sideways 8 that's big. They're bigger.
this infinity is ever so slightly smaller than this infinity. How much smaller? How much smaller? That single symbol.
It's bigger by one number, which is 0.
It's actually bigger by nothing.
Wait.
And
people say number theory isn't interesting.
there's like only one thing that doesn't have an answer in that, which is that. So everything else there is an answer. Basically.
Now, you people, being the intelligent young people that you are, already know that the natural numbers fit into the whole numbers. What's missing as we go to the next level? No, negatives first. The integers are the whole numbers, which are the natural numbers plus 0. The integers are the wholes plus the negatives. And that is the next biggest box. How many integers are there? An infinite amount of integers. The exact same amount as there are of whole and as there are of natural. But how can they be the exact same amount? Because the integers have all those negatives.
Does that mean 0 counts as an integer?
Yes.
It has the exact same amount as whole numbers. And whole numbers include 0.
Yes, that's what he means.
So why is 0 an integer?
I don't know, why don't you write a 1 when you have H2O? You don't write H2O1. It's kind of implied.
-0.
All right. Now, ladies and gentlemen, you've broken math. Okay. Ladies and gentlemen, this is where I draw a line. Because what is missing in all of these? The decimals. Now, decimals are just fractions' ugly cousins. Fractions are what is missing. Okay? So these ones have no fractions. And because they have no fractions, they automatically have no decimals. Now, the reason math goes a little haywire, one of the major reasons that math causes people difficulty, is because at around about grade 3, just when you think you're getting cool with math, right? 4, 3, 7, right? 7 times 9, 63, right? Right around then, you're like, I got this. I am all up in this math. But what you're really saying is, I got my gold star. Until about grade 3, when your teacher says, kid, and you say, yes, Mrs. Bagcrumble, and she says, draw me the number line. And you go, okay, Mrs. Bagcrumble, 0, 1, 2, right? And you're like, can I have my gold star? And Mrs. Bagcrumble says the word that you never hear from teachers anymore. She says, no. Because you have not drawn the number line, because Mrs. Bagcrumble is about to blow your mind again and say, 1.5. And you're like, what the hell? But you know about halves. And I'll tell you what. You go for minors. Oh, yeah, no, she is. Yeah. Oh, I will. Oh, are you sure? Okay. Yes, no. Go see Mr. Sadu.
Me?
Yeah, you. You're not in trouble. He went out of his way to say you're not in trouble.
Oh.
All right. You all do know what a half is because all of you, unlike people in my generation, go clean your room. No. You go clean your room. No. 1. And then you went and cleaned your room. Until you said no, and then your mom counted to 2. 2. And you were like, okay. And then, wait a minute. She said 1, and I didn't do it. And then she gave me 2. No, all right. No! And then your mom was like, because she didn't want to get to 3, because she didn't know what the hell she was going to do. Either. So she went 2.5. And you're like, what the hell's a half? Okay, so Mrs. Bad Crumble hits the half, and you're like, whoa, okay, I got you. The next thing's 3, and then I'm going to be in trouble. And then Mrs. Bad Crumble says, no gold star for you. And she goes there, and what's that? 1 3/4. Then you think, yeah, no problem, I'm good. And then she goes, no, you're not. What's that? 1 7/8. And then she says, no, what's that? And you go, that's 1 15/16. And then Mrs. Bad Crumble says, how many times can I cut that in half? And you say, well, you'll get to 2 eventually. And Mrs. Bad Crumble says, no, you never will. Because how far is it from 0 to 1? Infinity again. That is where math goes. For those of you that can internalize that concept, you're like, bring it. And for the rest of them, they're like, I no longer can 8 math stuff, numbers, blah. And then, of course, your English teachers walk into your math room and say, I can't do math either. It's okay. Right? Because you've all heard that. Can you imagine what it would be like if I walked into the English teacher's room and said, oh, I can't read. It's okay. Can you imagine the uproar if I did that? But everybody has no problem coming into math class. Oh, I could never been good at math. You'll be fine. But I don't go into other people's classrooms and do that. You know why? Sure. All right. So the rational numbers is everything else. Kinda. As long as the number can be written this way, x over y, like a fraction, and x and y are integers. And there's 2 conditions. Y cannot equal 0. Because if you divide by 0, it's infinity. And that doesn't exist. Okay? Now, here is where I ask some very simple questions that require a yes or no answer. You don't need to write them down. You just need to think. Is what I am about to write a rational number? Don't write it down. Just think. 2/3. Negative 2/3. Wow, usually I have to go 3 or 4 into this before I get disagreement. I'm on my second one. Of course it is. Is 2 an integer? Negative 2 an integer?
Yes.
Is 3 an integer?
Yes.
Does 3 equal 0?
No.
So that's a rational number. All right. Okay. Wait. 2.1 over 3.7.
Get that out of here.
Yes or no?
Yes. Because it's
No, you guys.
This is celebrity death match
Oh
here.
no, it can't be. No.
Oh no, integers. He said integers.
Okay, let's take a vote. How many say that is a rational number? Hands up for yes, nice and high. How many people think it is a rational? How many people think it is a rational number? How many people think that it is a rational number?
1, 2, 3, 4, 5, 6, 7.
I'm not doing it. I'm going against you.
That's how many.
How many people think it isn't a rational number?
Is it irrational? Is it irrational or is it?
That is 21 over 37, which is a rational number. So that is a rational number. What part of is it a rational number was confusing for those of you that left your hands down? Okay, stop. Stop.
He just nodded a lot.
Stop.
That's not for me.
He's basically saying this, right?
Go for Myers.
Wait, is it go for Myers? Is it go circle?
Basically what?
Roman, your turn to lead. You, too, are not in trouble. Now, okay, are we ready? Roman, this is going to be some good comedy. You might want to walk a little slower. 1/3 over 2/5. Now, I'm not going to twitch my head at all. Is this rational? Yes or no? Hands up for yes. Hands up for no. You cannot vote for both of them. Do you think because you have a different color, I'm not going to notice there was a black arm up and now an orange arm? You've changed your mind? What part of... This is 1/3 divided by 2/5, which is 1/3 times 5/2, which is 5 over 6, which is a rational number. It is a rational number in a form that it is in. All right. Now, stop. Let us now deal with fractions' ugly cousins. The ones that you all want to deal with, because fractions still scare you, because I think of your latent tendencies to remember your parents counting. I think that's why fractions scare you all, because your parents were 1.5, and they would do that big parent voice thing, and you would think you were in trouble. Of course, my parents, like I said, do that. No, there was no counting. But I turned out okay, I think. Fractions' ugly cousins.
But my dad, when he counts up to 10, he goes up to like 3 and he skips to 7.
Well, that's not going to help at all. That's like iCarly. Derp. That's not going to help at all. That was the best episode. I know. I love the Derp episode. The new number between, is it 5 and 6 or 4 and 5? Between 5 and 6. If you don't know what we're talking about, go home and check out Nick Plus or whatever iCarly is on now. I don't think it's on Netflix anymore. What do you need, Ethan?
What was I going to say?
I don't know, because I don't have the world's worst superpower.
Okay. That just proves when people are like, oh, I'm really bad at math.
All right, yeah, exactly. Your dad's supposed to teach you how to count. He skips to 7? All right. So decimals. Now, decimals are easy to deal with sometimes. For example, you all agree that 1/2 is a rational number because it's 2 integers, right? It's also 0.5.
Yes.
Excellent. You all agree that 3, we'll do 1. 1/8 is 0.125, right? How do you find the 0.125? You do 1 divided by 8 with your calculator, yeah?
Yeah.
All right. So it's pretty easy, right? Now, where it starts to get a little weird is this. Is that a rational number?
Yes.
Of course it is, because it's 2 integers. But when you punch that into your calculator,
It's a repeating decimal.
it fills up the screen. For how long?
For infinite.
It'll go forever. And everyone's like, oh, okay, yeah, all right, obviously fine. So sometimes a decimal will end. 0.5. Done. Rational number. Sometimes it will be more than one decimal, but it will end. Done. Rational number. Sometimes it'll repeat. Obviously, if this is rational and this equals this must be rational. It repeats, no problem. But then we get into weird stuff because you guys blame your calculator or believe your calculators over your brain. 2/3 on most calculators will come up as 0.666666666, and then you'll get to the end and it'll say 7. No, it's not dumb. It's your calculator doing math properly because your calculator doesn't have a screen that goes to infinity. And the next number here would be a 6, which is bigger than 5, so that rounds to 7. But the problem that kids have is you don't listen to what's actually happening. You listen to the words. And the words say it repeats or it ends. But the word they use is terminate. It repeats or it terminates. And most kids are like, okay, I got you. Easy. But then they see this. And all of a sudden, they're like, well, that doesn't repeat. That's a 7, and these are all 6s. You're not like that. You know what your calculator is doing. All right? So, to succinctly put it, if you have a decimal that ends, no matter how many digits it has, it's a rational number. If it repeats, no matter how many digits it has, it's a rational number. Okay? Okay. Loud.
How do we determine an irrational number on our calculator?
I'm about to tell you that because as you can see, the very next heading is irrational numbers. For our purposes, the irrational numbers are simply what I'm about to show you. There are millions of them, of course, like everything else. But for our purposes, an irrational number is something without a square root. I shouldn't say that. It is something when this will fill up our calculator screen. All right, and here is what I mean. Square root. Square root 9.
Is that a virtual calculator?
It is indeed. 3. Rational. It ends. Square root 2.25. 1.5. Decimal. Ends. Square root 2. Screen fills up. No repeating. For our purposes, if the screen is full and it doesn't repeat and there's a square involved, or I shouldn't say a square, that symbol is involved, you have an irrational number. There are some famous ones. Pi, e to the x, which is Euler's constant, I believe it is called. It's something like 2.78, blah. Pi 3.14, blah. C is another one. None of them matter. Okay? They're just numbers that go on forever. Now, the problem, keep your thoughts in your head, keep your questions, I'm coming to them. The problem with irrational numbers is something like the square root of 1.96. Most of you would say, look at that, see square root, see a yucky number under there, and assume that that was irrational. It is not. That is 1.4. So that is rational. Everybody cool? Now, I saw 3 hands that I asked you to put pins in your thoughts. Go now. Ethan.
You said all the irrational numbers like pi are useless, but don't you use pi?
No. I don't mean useless. I mean that you don't have to, like, you don't have to know where they come from or what they are. Like, the fact that we say 3.14 is enough, right? If we were using Euler's constant, we could use 2.78. It's enough. Like, there's always these things like, oh, he memorized pi up to 10,000 digits. Well, did he really, or is he really quick at dividing and keeping a a remainder going, right? 3.14159, and then I'd have to stop unless I could keep the division going quickly. And everybody thinks that's some sort of measure of intelligence, but it's not, right? Like I've memorized all the words in the English language that I'm ever going to use. Does that make me smarter than anybody else? No, because here I am talking to you with all the words I'm ever going to use in the English language. I don't know any words in Sanskrit. Does that make me unintelligent? No, it just means I don't know Sanskrit, right? Next. Gideon. What? No, the square root of 2 is an irrational number. Ethan.
Maybe this is off topic, but where do we get things like
pi is the number if you measure a circle and you divide the circumference by the diameter. Now, the problem with that is everybody knows pi equals circumference divided by diameter. And then everybody says, well, that's a rational number. How can it not be? Because a circumference must end, right? Like this must be a distance. And this must be a distance. So how can this give us an irrational number? Right? That's a problem for people. Jayden, you put your hand up in the middle of my discussion there. Did you have something to add to this particular thing, or do you have something else going on?
I think maybe it's irrational because like circumference can mean anything.
So you're along the right track, right? Because what ends up happening is there's just always a remainder, and it goes on and on and on and on when you do this division. Are we good? Now, you will notice that I called this page, I made a joke about it earlier, the real number system, yes? Because these are all the numbers that are really out there that we use and can count and do stuff with. You're in the 10th grade? In about 5 years, if you continue to follow math studies, you will be introduced to not the real number system, because by then if you've been studying math for 3 years at university, you're pretty comfortable with the real number system. They will introduce you to the imaginary number system. And no, it's not 11. It is the square root of negative numbers. Things like that. They're an invention that we have to use sometimes to explain phenomena that are happening in the world. Like that doesn't exist. There is no such thing as a square root of -4, because a square root means 2 of the exact same factor. And if you multiply 2 things together, you always get a positive. Lala.
Would infinity be like a real number?
No.
So it's going to imaginary numbers?
Infinity is a concept. It's not a number. Right? Because no matter what that number is, n, you can always add 1. Right?
Yeah.
Just like cutting the distance between you and me in half. I'm never going to get to you, but I'm going to get to you. Right?
Yeah.
Okay. All right. You should be able to do that in literally about 1 second. What is that as a fraction? Think back to Mrs. Bag Crumble's lessons on place value. 12 over 100. Does that get you full marks? No. What is it? 3 over 25, right? Oh, you can do that. No big deal. Ease peas, lemon squeezy, yeah? Jake. Huh? You could write 1.2 over 10, but that's not a fraction that we would ever write, would it? You guys all got mad at me earlier when I put fractions over decimals over fractions, and we're like, no! No! All right. Some of you know the trick for B already. You already know the answer. What is it? 1 over 9. For 5 gummy bears. Why? And don't say, because whenever it's repeating, it's over 9. Okay, Roy?
When you divide 1 by 9, it will be 0.1, and
That's-
there will be 1 remaining, which continues on. So it will be
You may have 3 gummy bears for that definition. Yes.
Yeah, we probably already have like a full class.
No, Roy only has 1. Well, he got interest on that one now, but now he's got 3 more.
So wait, the more gummy bears that you have, like, does it work like the amount of money that
Can we do math?
Yeah.
Okay then. All right. Gideon.
The reason that it is 0.1 repeating is because when you divide, when you divide 1 by 9, you do get the 11, right? And it repeats. Yeah?
So that was word for word what Roy just said.
Wait, it is?
Like word for word. So,
I didn't pay attention.
Ethan. I see your hand, Josh. You're next. Ethan.
Okay, so this is probably going to be exactly what there is, but when you divide 1.
We're starting out the same. When you divide, I like how you add some gestures and make it sound like you're saying something different. Kind of like the guy down there, right? You're not saying anything different. You.
It's because 0.9 repeating is it's like treated as the same as 1. So wait.
Where'd you get the 0.9?
Because it's because 0.1 repeating times 9 is 0.9 repeating, and 0.9 repeating is treated as the same as 1, which would be 10. But it's like wait.
I believe, Josh, that you have a place you are going. I'm just a little lost on the path. But I hear what you're saying. I hear you. Rachel? Pardon me? It's a repeating decimal. Yes.
You should give Josh one of the 2 missing gummy bears in the board. Still have 2 left that you promised somebody, so you should give them one of them.
But I promised 5 for the definition.
You can't pay for it.
Okay. We're going to talk about why right now. Retry.
Please, this one actually is good, and I know
Okay. Did Roy tell you?
No, but
Okay.
I figured this out. Okay, so essentially because you have 0.1 repeating, because it's that small of a decimal that's repeating in some, because it's not a 3 or a 6, it can't be divided by 3. Therefore, it has to be divided by 9 by deduction.
Except on a day that ends in Y when it's... Okay, here is the real reason.
Math.
Because math. If I take that bar away, what do I have?
0.1.
Which is?
0.1.
1/10. Yes? A rational number must have integers, yes? Is slightly bigger than 0.1? Yes. So I must need an integer on the denominator that is the slightly bigger fraction of this one. What is the next integer? It would have to be 11 or 9, yes? In fractions, as the denominator shrinks, the number gets bigger. So that is why it is 1/9. Is that what you were going to say?
Yes, that's exactly what I was going to say.
Well, you're back there like... yeah, that's exactly what she did. She dropped her pen and went... I don't know about you young hip kids, but when I was your age, this meant I got it. So what's this one?
0.222
2 over 9. Now, is this one, the way it is written, guaranteed to be a rational number?
No.
Why not? Jayden. There's no line. There's no line at the top. This just means this carries on. The millionth decimal might be a 3. Everybody with me? This, rational. This appears rational. Everybody cool? All right, and lastly, what happens when we got sum of each?
54 over 99.
So we got 54 over 99. Good guess. If I do that with my calculator, I will get 0.545454. Excellent guess. Is that right? Why not? Because what's this? This is 5, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, Lala.
It's isn't it 54 over 90?
54 over 90. Well, 9 goes into both of them, doesn't it?
Yes.
So that would be 6 over 10, yeah?
Yes.
Which would be 0.6, yeah? It's not. It's 0.54. Gideon. 5.4 over 9. Ooh, gutsy. Let's see. Let's get out my good friend TI-84 and go 5.4 divided by 9. Oh! Busted.
Wait, is it 49 over 90?
49 over 90. I don't know. Let's see. 49 divided by 90. Dun, dun, dun! He's as cool as Belton Crudes. Why?
I don't know. I just did it and then I forgot it.
There is a shortcut here. The shortcut is simply this. If the bar was over all of it, Josh is right? It's 54 over 99, yeah? But only one number repeats. So on the denominator, we can only have 1 9 because only one thing repeats. Nothing else repeats. All right? Now, if I do 54 over 90, we saw that's 6/10. That's no good, right? So what you do is your numerator here is what you have, 54, minus the 5 that doesn't repeat. So you get 49 over 90. It's just something weird that happens to work out. A lot of the math that we take for granted are patterns that people worked out thousands of years ago before they spent all their time watching cat videos. Okay?
Like the 1970s, right?
Yeah. I think that when they mentioned that, that was like when, what was his name?
Yeah, in the 60s, they just kind of
invented math.
Arithmetes. Famous Greek. All right, so your job tonight, and this is easy peasy lemon squeezy, you have to fill these in, and you put the smallest group that each number fits in. All right? So if it's a natural, that's all you have to write. Because if it's natural, is it automatically whole and automatically an integer and automatically rational? Everybody good? All right. And then you do page 29. Now, if I am not mistaken, I did not collect your quiz marks yet. Did I or did I not? It was out of 11. I did not. Okay. I would like to get to that today, but it is 2:17, so I do not know if I will. Gideon, what were you asking me?
Didn't you say we weren't going? Oh, you're just training us to get out of the use of our calculators. But how are we supposed to do things like question A here without our calculator?
How are you supposed to do A without your calculator?
It's something easy. We fill out our calculators.
Let me ask you this. Does the square root, without touching your calculator, does 6 have a square root?
No, it doesn't. No, it doesn't.
It does not. It doesn't have, so that makes it irrational, right? Okay. So are there, what does that little 3 mean? cubed. So I need 3 numbers, right? Square root of 4 is 2, because 2 times 2, 2 numbers. Square root of 9, 3. 3 times 3. So I need a group of 3 numbers, yes? Are there 3 factors that are the same that will multiply to 14? No. So it is irrational. Done. Without a calculator. Because you understand numbers. Let's do B together. What is the square root of 25? 5. 5 is natural. What about that one? Why? Because it ends. That is 319,754 1/millionths. So it is rational. Okay? Carry on, my wayward sons and daughters. There. Now you will notice on page 29 you have the answers here. Answers don't help if you don't know why. And that is thaumaturgically phallus. That is a thaumaturgical fallacy.
Yeah.
I just made that word up. Thaumaturgical doesn't mean anything. But it sounded good.
Therma? I thought it had
Yes. 28 and 29. That's your only work
When
today.
you said the word, you sounded very hypocritical.
Pardon me? Of course.
Yes. Mr. Myers.
You found it very hyperhidrosis, which is sweaty. It's a true word.
That word is pretty close.
Woo! Fun class, ladies and gentlemen. Oh, my giant eraser.
That wasn't me. It was already messed up. I just made it smoother.
It's like perfect. You sat and erased, like, thanks. Now it's not covered in finger scunge. She erased all 8 or 6 sides of my eraser, so it's like back to being almost newly whited. Because she did the thing where you scrape off the scunge by her. Never mind. Just do your math. Thanks, Mia.
I got this though.
You got a big pile of eraser dust now? And it's, ew, grody, because it's covered in finger scunge.
No. I've done that since like elementary school.
I like a nice eraser too, but I'm not that OCD. I just keep the ends tidy.
I would have made them flat, but
Okay. Note to self.
You already did.
Yeah, I did it already.
Nerd.
Hey.
See, you two want to sit there. Everybody jokes about it in the first little while, and then I move people out of there, and they're like,
I never had an issue with laws, though.
can I move back to the front? Nope.
Because with alphabetical order, we always sit next to each other.
Of course you do. But in here, it could have worked out that he was back where Gideon was, and you were here. It's possible.
Oh yeah, that could have been, yeah.
Could have been. Yes, it is. Whoever said that.
Oh, if there was one person before us.
Nice job. Ethan got number something about F.
Well, yeah. Is
it? Well, then why are you asking me if you already know the answer? Of course it's not rational. That's the actual example I gave on the previous page. Like, that is the exact thing I wrote. So, well, again, that is the exact thing I wrote. There you go. Yeah.
I
Alright.
Rational or imaginary?
It's imaginary because you cannot have a negative square root.
Aditi, you had your hand up. What? Oh, I thought you did. Carry on then. Oh, there's the bell. Put your chairs up. See you tomorrow. Normally you would have had more homework time, but for some strange reason, the real number system was utterly hilarious to you all today.
Mackenzie, tomorrow we have the thing for with the district.
That wasn't even a sentence. Tomorrow we have the thing with the dis thing.
The district.
Oh, the district. Oh, I didn't hear that part.
Wait,
The one with the... Yeah, that one. No, not the one...
where we went to Braden. The same. We leave in the middle of. We need to be there at 11:20ish, and then I don't know what time we get back. Maybe
So you're not going to be in my class? If you're leaving at 11:20, you're in this class.
We have this class. I have this class first.
Oh yeah, you're first tomorrow morning. Well, lucky you. That's the way to start the day.
Thursday, but then he's like, oh no, it's tomorrow. And then
Nice backpack, Ethan.
he's like, I don't remember the other kids' names. You got it?
We've gone over this. Twinsies! Everybody went to Costco in September.
Anyways, do you know where Braden is right now? He's coming to
Which Braden?
Smith.
I know that Braden.
I know he's coming.
Have good days.